morning, friends. We completed the theory of chapter 13, kinetic theory. After that, we are start our discussion about the illustration and also the numerical of exercise. Now, before starting the illustration, this numerical of illustration I cancel 13.1, 13.2, 13.3, 13.6, 13.7 and 13.9 I cancel. Remaining are 13.4, 13.5 and 13.8. Okay, first we consider the illustration 13.4. A vessel contains two non-reactive gases, neon monoatomic and oxygen diatomic. The ratio of their partial pressure is 3:2. Estimate the ratio of number of molecules and second, mass density of neon to argon. Atomic masses of neon is 20.2 atomic mass unit and for oxygen 32 atomic mass unit. Now, in a vessel, the two gases, neon and oxygen, neon is monoatomic while the oxygen is diatomic, are filled in a vessel. Both are non-reactive. And also, partial pressure is 3:2. In this case, we have to find out the ratio of the number of molecules in these two gases. And second, we have to find out the ratio of the mass density of neon to the oxygen. Now we know the equation of state for the gas PV is equal to mu RT. Both gases are filled in a vessel at the same temperature. Therefore, PV is equal to constant. Okay, now we add it. Now from the equation of state, or first we consider neon as gas 1 and oxygen as gas 2. From equation of state, for neon, P1V is equal to mu1 RT, and for oxygen, this equation P2V is equal to mu2 RT. Both are kept at the same temperature and same volume, that means same vessel, therefore V and T are constant. But the quantity of the gas are different, right? Therefore, here V and T are constant. Therefore, from the ratio P1 upon P2 is equal to mu1 upon mu2. So the ratio of the initial pressure, that gives the ratio of the quantity of neon and oxygen. Therefore, mu1 upon mu2. P1 upon P2 is given, that is the 3/2. That is the 3/2. That is the equation number 1. Now, from definition of mole, mu is equal to number of molecule and divided by Avogadro number, right? Therefore, from the definition of mole, N upon N, N upon N. Therefore, mu1 is equal to N1 upon N, and mu2 is equal to N2 upon N. Right? Substitute in 1. In equation 1, we obtain mu1 upon mu2. mu1 upon mu2, N1 upon N, divided by N2 upon N. N cancel, therefore N1 upon N2. But this ratio is given 3 by 2. That is given as 3 by 2. So thus, our first answer is that number of molecule, ratio of number of molecule in 1 upon N2. That means number of molecule in neon to the number of molecule in oxygen is also 3 by 2. That is our first part. Now the second part. We have to find out the mass density, ratio of the mass density. Now again, from the definition of mole, under the equation of mu is equal to number of molecule per mass of the atomic mass. Mu is equal to m upon capital M. Using this concept, mu1 is equal to m1 upon m1 and mu2 is equal to m2 upon capital M2. Capital M. Now, M1 and M2 are the molecular mass of the neon and oxygen. Capital M1 and M2 are atomic mass of neon and oxygen respectively. Now density rho is equal to mass upon volume. Mass upon volume. Density is equal to mass per volume. Therefore, rho1 upon rho2. Here the volume are same. Therefore, m1 upon v upon m2 upon v. We cancel m1 upon m2. Now listen, from this equation, what is the value of small m1? Small m1 is equal to mu1 capital M1 and small m2 mu2 m2. Therefore, the ratio of the density is rho1 upon rho2. Rho1 upon rho2 is equal to mu1 upon mu2 into bracket m1 upon m2. But the mu1 upon mu2 already we obtained from equation 1. There is some 3 by 2. And M1 is the 20.2, M2 30. If we simplify it, we obtain that is the 0.9468. That means the 0.947. That is the ratio of mass density of neon to the oxygen. That is our second answer. Again, in this equation, vessel contain the two non-reactive gases, neon monoatomic and oxygen diatomic. The ratio of their partial pressure is 3:2. Estimate the ratio of the number of molecule and mass density of the molecule, mass density of neon and oxygen. Atomic mass of the neon is 20.2 atomic mass unit and oxygen 32 atomic mass unit. Consider the neon as a gas 1 and oxygen as gas 2. Therefore, from equation of state for gas neon 1, neon P1V is equal to mu1 RT, and for oxygen P2V is equal to mu2 RT. So here the volume and temperature are constant. R is also constant. Therefore, taking the ratio of these two equations, P1 upon P2 is equal to mu1 upon mu2. But here P1 upon P2 is given ratio 3 by 2. That is the equation 1. Now we are interested to obtain the ratio of number of molecules. From the definition of mole, mu is equal to n upon Na Avogadro number. Therefore, for neon, mu1 is equal to n1 upon Na, and for oxygen, mu2 is equal to n2 upon Na. Substitute in equation 1. Therefore, mu1 upon mu2, n1 upon Na upon n2 upon Na cancel, n1 upon n2. But from equation 1, mu1 upon mu2 is equal to 3 by 2. So, n1 and n2 are the number of molecules in given gas. Therefore, the ratio of the number of molecules in given gas is also 3 by 2. Now we have to also find out the ratio of the mass density of neon and oxygen. Again, from the definition of mole, mu is equal to mass of a molecule upon atomic mass. Therefore, for neon, mu1 is equal to small m1 upon capital M1. And for oxygen, mu2 is equal to small m2 upon capital M2. M1 and M2 are the atomic mass of neon and oxygen. Now, density ρ is equal to mass upon volume. Therefore, ρ1 upon ρ2, that means the density of neon to the density of oxygen, m1 upon V upon m2 upon V. Volume are same, cancel, so it's equal to m1 upon m2. Now, from this equation of mu1 and mu2, small m1 is equal to mu1 into capital M1, and small m2 is equal to mu2 into capital M2. Substitute here. Therefore, ρ1 upon ρ2 is the ratio of mu1 upon mu2 into m1 upon m2. From equation 1, mu1 upon mu2 is 3 by 2, already we have. And now, m1, atomic mass of the neon 20.2, and m2, atomic mass of oxygen, that is 32. It is simplified. This ratio is 0.9468, that means the 0.947. Okay? Okay. After that, the same numerical. A flask contains iron and chlorine in the ratio of 2:1 by mass. Ratio of their masses are given 2:1. The temperature of the mixture is 27 degrees centigrade. Obtain the ratio of first base kinetic energy per molecule, and second root mean square speed VIMS of the molecule of the gases. It means we have to find out the ratio of base kinetic energy per molecule and the VIMS of the molecule of the gases. VIMS of argon to the VIMS of chlorine, and we have to find out the kinetic energy of argon to the kinetic energy of chlorine. Atomic mass of the argon is given 39.9 atomic mass unit, and chlorine is 70.9. Now we know that the base kinetic energy per molecule of a gas is a base kinetic energy of molecule is half m this square. A base is equal to 3 by 2 kb. Now, the temperature of both gases are constant, that is the 27 degrees centigrade. Therefore, the kinetic energy per molecule for given both gases are also same. Now, first answer the first part. Here, temperature of here, a base kinetic energy of molecule is directly proportional to its absolute temperature. A base kinetic energy of molecule depends on its absolute temperature. Here, temperature of both gases are same. So, kinetic energy of argon is same as the kinetic energy of chlorine. Therefore, ratio of kinetic energy of argon to the kinetic energy of chlorine is 1. Now we are interested to find out the ratio of the VIMS of I want to the VIMS of molecule of fluorine. Again, we consider a base kinetic energy. A base kinetic energy per molecule is half m v square is equal to 3/2 kBt. 3/2 kBt. Right. Therefore, a weight square is equal to 3 kBt upon m. 3 kBt upon m. Here 3 kBt is constant. Therefore, we know that a weight square is proportional to the 1 upon m. Taking the square root, therefore VIMS is equal to square root of a weight square proportional to the 1 upon under root of m. 1 upon under root of m. Therefore, VIMS of I1 proportional to the 1 upon under root of mass of the molecule of I1, and VIMS of fluorine proportional to the 1 upon under root of mass of fluorine. Therefore, the ratio of VIMS of I1 to the VIMS of fluorine is equal to under root of mass of the chlorine to the mass of I1. Mass of the chlorine to the mass of I1. But mass of fluorine is equal to atomic mass, you consider. And mass of molecule of I1 is the mass of atomic mass of I1. Therefore, our equation becomes VIMS of I1 to the VIMS of fluorine is equal to under root of atomic mass of fluorine upon atomic mass of I1. Atomic mass of fluorine and atomic mass of I1 are given. So it's equal to under root of 70.9 divided by 39.9. So that is the square root of this ratio is equal to 1.7769. So the square root is 1.33. Thus the ratio of VIMS of molecule of I1 to the VIMS of molecule of fluorine is 1.33. Very easy numerical. So the base kinetic energy of molecule of a gas is half m. A weight half m display is equal to 3/2 kB. Right? Here, the base kinetic energy of molecule is directly proportional to its absolute temperature. But here the temperature of the both gas I1 and fluorine are given same, that means the 27 degrees centigrade. Therefore, the kinetic energy I will also same. Kinetic energy of molecule of I1 and fluorine gas I will also same. Therefore, kinetic energy of I1 to the is equal to the kinetic energy of fluorine. Now taking the ratio, kinetic energy of I1 to the kinetic energy of fluorine is 1. That is our answer to the first part. Now, we have to also find out the root mean square speed, VIMS of molecule of the gases. So, a base kinetic energy per molecule is a weight half m square is equal to 3/2 kBt. Therefore, a weight square is equal to 3 kBt upon m. 3 kBt are constant. Therefore, taking the square root, VIMS is equal to under root of A weight is square proportional to the 1 upon under root of m. Therefore, VIMS of iron proportional to the 1 upon under root of mass of iron molecule, and VIMS of chlorine proportional to the 1 upon under root of mass of chlorine molecule. Therefore, taking the ratio VIMS of iron to the VIMS of chlorine is equal to under root of mass of chlorine molecule to the mass of iron molecule. But here we can consider the mass of the chlorine molecule is equal to its atomic mass, and mass of the iron molecule is an atomic mass of iron. Therefore, VIMS of iron to the VIMS of chlorine is equal to atomic mass of chlorine to the atomic mass of iron. Now we substitute the value of atomic masses. So square root of atomic mass of the chlorine is 70.9 and atomic mass of the iron is 39.9. As we simplify it, we obtain 1.7769. Therefore, this ratio is 1.33. Clear? So, generally, this type of the numerical may be asked to find out the ratio of the VIMS. Clear?